Namaskar and welcome to StudyIQ. I am your friend Rahul. The agenda for today's discussion is connected with space technology. We are going to discuss about a very important space project by NASA called as OSIRIS REx. Now you're thinking, sir, I've already heard of OSIRIS REx. It was launched almost 7 years back in 2016. Then why are we discussing about it now? The project has completed one of its important objectives. OSIRIS REx has recently successfully delivered NASA's first asteroid sample from the asteroid Bennu. In this video lecture, we'll understand everything about OSIRIS REx and this successful delivery of sample from the asteroid. In the latter half of the discussion, we'll also talk about what is the successor project to OSIRIS REx. To get to know all this information, stay with me till the very end. You'll get very interesting information. All right, let's begin. But before that, if you're preparing for UPSC Civil Services Examination, StudyIQ's P2I program September batch is closing out at the end of the month. You can get yourself admitted till September 30th. This would be one of the last batches for preparation for 2024. And you do know that P2I offered by StudyIQ is the most comprehensive program for UPSC Civil Services preparation, where we will be hand-holding you through prelims, mains, and interview, all the 3 stages. It is quite affordable. Just visit our website, studyiq.com. You'll get all the information there. Enroll soon. I'll see you in the class. All right? Right. Let's begin our discussion about OSIRIS REx. OSIRIS is an acronym. OSIRIS stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. Now, regolith means soil explorer, and soil from where? Soil from an asteroid called as Bennu. And I told you that OSIRIS REx was a project which was launched in 2016, 7 years back. NASA started its voyage where this particular project would go on the asteroid Bennu and collect some samples. Now you have a question, sir, why was this asteroid Bennu selected for this regolith exploration? It was selected first of all because it is closer to Earth. The asteroid also revolves in an orbit, and at one particular point its perigee is quite close to the Earth. Apart from that, Bennu is a huge asteroid. Its diameter is around 500 meters. To be precise, it is 492 meters in diameter, and it rotates slowly. Now, once it rotates slowly, that means the regolith or the soil, it stays on its surface. So I can go there on Bennu and I can collect the sample. Apart from that, Bennu, very important, it is one of the primitive asteroids. And if I get sample from here and analyze that sample, I can understand and unravel the secrets connected with the Big Bang or the beginning of the universe itself, isn't it? Now, apart from that, I also received one of an interesting question when I discussed OSIRIS REx before as well. One of the students had asked, sir, why the name Bennu? Right? Why the name Bennu? Again, remember, there are millions of asteroids. You do understand asteroids are found predominantly in the belt between Mars and Jupiter, the asteroid belt. There are also some Trojan asteroids. And the nomenclature of asteroids is quite interesting. How are the names given? The names, first of all, from 1925, since the beginning of the International Astronomical Union, whoever discovers, say for instance, I discover an asteroid. I have a telescope, I discover an asteroid, I give an application to IAU, International Astronomical Union, suggesting that this is a new asteroid which I have found out. First, the International Astronomical Union will give it a number. It will be identified by a number. Later on, whoever has discovered it, they can propose names, and such names are selected. Again, such names should not be controversial or should not be degrading to any community, etc. You do understand all the rules and regulations, and the nomenclature is based on the proposal made by discoverer. That's why the names come, and that's why you will see so many different kinds of names. Earlier, before 1925, before the International Astronomical Union, the names of asteroids were decided on the basis of historical figures or Greek or mythological characters, gods, goddesses, etc. You must have heard about so many names of asteroids like Agamemnon, Achilles, right? Such asteroid nomenclature was before the coming of International Astronomical Union. But now it is the IAU which decides the names. That was just out of context because I remembered a question asked by a student. So I hope now you're clear why Bennu was selected. First of all, it is a little closer to Earth. The soil, it stays on it because it rotates slowly. Apart from that, it is a primitive asteroid. meaning I can research on it and I can unravel the the secrets of the beginning of the universe itself. Apart from that, Bennu is of interest because it is a potentially hazardous asteroid as well. Now, please remember there is a term called as PHA, which is used with the asteroids. Why? Because this asteroid has a probability of coming and hitting the Earth, not now, way in future, right? Because Bennu's orbit brings it very closer to Earth within a range of about 200,000 miles near the Earth, and probably say in the late 22nd century, there is a probability of Bennu impacting Earth quite late. Will not be alive at that time. But again, those are called as potentially hazardous asteroids, meaning they come very closer to the orbit of Earth and they might be impacted by Earth's gravitational force, and there is a potential chance of impact. Those are called PHA. Again, this OSIRIS REx mission, as I told you, it is a mission launched by NASA. It was launched in 2016. I told you why we selected Bennu. Its size is quite high, 492 meters. And remember, it was also selected because it is primitive, and this particular asteroid has carbon content in it. Again, when we get the data from the sample, we'll talk about it more and more. But the mission, it started in 2016. Around 2018, the spacecraft, that is OSIRIS spacecraft, it started to rendezvous with the asteroid Bennu. Later on in 2020, it landed on it and it collected sample. On October 20th, 2020, OSIRIS REx touched down successfully on asteroid Bennu and it started collecting samples. Now, it was suggested that it will collect soil along with some rocky fragments, etc. And during the collection of the sample, the flap was supposed to be closed once the sample was collected. But when the sample was being collected, one of the huge boulders or one of the rock structures, it jammed the flap, and because of which some of the sample, it fell down. According to NASA statement, they were supposed to get somewhere around 1 kg, almost 600 to 1 kg of sample from asteroid Bennu. But because of some issue with closing of the flap, some of the sample, it did not get caught with the sampler. But despite that, NASA is quite confident that they will be able to get large amount of sample. And now NASA has suggested that this particular OSIRIS REx, which has returned the sample from asteroid Bennu, it is about 8 ounces, that is 227 grams of sample has been sent by OSIRIS REx, the spacecraft, from asteroid Bennu to Earth. And that is the news. That is why we are discussing this, because in September, on September 24th itself, as planned, NASA's OSIRIS spacecraft, it successfully returned the sample. Remember, the spacecraft itself did not return. The spacecraft simply left the sample which was collected. The sample holder was there. It is tightly packed. Again, it re-entered the atmosphere and it was deployed. A chute was deployed. You can see here, this is from the Utah desert in USA. You can see the sample here and the parachute as well. Later on, it was collected from the Utah desert and it was transferred via a helicopter to a safe laboratory, and this is the sample. In fact, if you must have seen that live as well. NASA had streamed all these things live. If you want to watch the video, you can simply search for OSIRIS REx sample return on YouTube. You'll find a very lengthy video, almost 2-3 hours of video, where the entire process was shown live itself. Now, this is a sample which is there in a safe facility now, isolated facility. It has not been opened yet. You can see it almost looks like burnt, because once it enters Earth's atmosphere, because of the friction, you will see so much of heat, and the sample is inside this particular sample holder. It will be removed soon and testing would be conducted on that. Now you must be thinking, sir, what is the significance of this? How will it help? See, first of all, Bennu's entire sample, first of all, it had collected some of the rock fragments as well. But what scientists say, the scientist who's leading this, the principal investigator, is Dante Lauretta. Dante Lauretta had said that by now, inside this particular sample holder, it would be completely powder itself because of the speed with which it entered into the Earth's atmosphere. But nonetheless, they will be able to analyze the materials quite successfully. Apart from that, Bennu's samples are pristine than any of the meteorites even reaching the earth, because they have not entered earth atmosphere in a naked way. Basically, they are inside an enclosure. Now you do understand, when a meteorite it enters earth atmosphere, it will undergo the action of friction. There will be some sort of burning. We have seen meteor showers later on. Meteorite reaching the earth itself, it would not be completely pure, pristine, because it interacts with earth's atmosphere. But this particular sample is quite pure, and it is one of the largest samples that has come from any body beyond the moon. And the principal investigator, Dante Loretta, they say that these samples, they hold the key to seeds of life. That means they will help us understand the prebiotic chemistry which eventually gave life on Earth. The investigator, Dante Loretta, he thinks that Bennu has about 10% of water, again, not in the liquid form, but locked up in the rock itself. And we have now collected some rocks and some soil samples. Apart from that, it also has about 5% carbon by weight. This is very, very important. That means it is a carbonaceous asteroid. That's why we selected that as well. Apart from that, the team is very keen on researching this because it is going to give us the answers probably regarding the origin of solar system itself, because it is one of the oldest and the primitive asteroids from which we have now collected samples. So we are all waiting now for the results to come up. The results will probably come up, say, mid-October. Whenever they are released by NASA, we'll have a discussion on that. But what is happening with OSIRIS now? The OSIRIS spacecraft, first of all, it delivered to us the samples from Bennu asteroid, and now it has moved on to its next mission. You heard me right. Now OSIRIS REx has been renamed or rechristened to OSIRIS Apophis, meaning the same OSIRIS spacecraft, after delivering the samples from Bennu, it is now OSIRIS Apex. It will now research on another asteroid called as Apophis. Now this Apophis asteroid was discovered in 2004. Now this is also classically a potentially hazardous asteroid because it comes pretty close, meaning it approaches within 4.65 million miles of Earth's orbit, and its size is also pretty huge. That means it is about 500 feet in diameter, meaning, say, approximately how much would be that in meters? I would say somewhere around 150 meters in diameter, a little less than that, a little less than 150 meters in diameter. So it is a potentially hazardous asteroid. It is a stony type of asteroid, and it does not contain that much of carbon and water according to NASA. But now this OSIRIS spacecraft is going to rendezvous with Apophis asteroid. Now this rendezvous will take place in 2019, when Apophis it is revolving in its own orbit, and when it comes closer to Earth on April 13, 2029, OSIRIS Apex will be the best seat from where it will be training the asteroid Apophis. It will go very close to that Apophis, somewhere around 30,000 kilometers. And here it is going to study the interaction of Apophis with Earth's gravitational field. During this time, April-May 2029, the Apex probe, it is going to investigate Apophis's reaction to Earth's gravitational field. It is believed that because of Earth's gravitational field, the asteroid spins about its short axis every 30 hours. But because of the gravitational field, it could change drastically. Some of the features might be changing. Because of the gravitational field of Earth, there might be landslides or boulder migration on asteroid Apophis. Once this is studied for almost a couple of months, then 2 months later, the OSIRIS is going to rendezvous with the asteroid. It is going to land on the asteroid, and then it is going to characterize its mineral and surfaces. In fact, this OSIRIS Apex mission, it is going to be much more complicated even than the REx mission. Of course, it is going to land there, and whatever fuel is left out now, the OSIRIS, after landing, it will go very close to the surface, say approximately 2 inches, that means 5 centimeters near the surface of Apophis asteroid. And then with the remaining amount of fuel, this probe is going to thrust, it is going to thrust into the Apophis asteroid itself. Once it thrusts, that means a lot of regolith, a lot of soil from Apophis is going to rise up, and this subsurface is also going to be studied. Meaning, it is not just the surface study of Apophis, it is surface as well as subsurface. After these thrusters will help in exposing the subsurface to the OSIRIS probe. Again, no sample would be returned, but a lot of details or insights would also come from this APEX mission regarding the asteroids Apophis. That is the update on OSIRIS REx, which has now become OSIRIS APEX. All right, we'll keep an eye on this. We'll keep an eye on research as well, as and when the details come, we'll discuss that on StudyIQ. But let me end my discussion by giving you some insight into asteroid research itself. It's actually golden time for asteroid research, not just from NASA perspective, but any other space agency as well. Now, we have already discussed about OSIRIS REx. Sample has come from asteroid Bennu. OSIRIS APEX, which is going now to the asteroid Apophis. Even before that, this is not the first time that sample has come from an asteroid. Hayabusa 2, which was launched by JAXA, the Japanese Aerospace Research Agency, it had returned sample in 2010 itself from one of the asteroids called as Ryugu. Again, this is not a carbonaceous asteroid. For the first time, sample from carbonaceous asteroid has come from Bennu. But even before that, Hayabusa had brought some of the samples. Apart from that, we have already discussed about the DART mission. DART mission, all right, the double asteroid redirection test. Now here, a system of asteroid, the dimorphos Didymos system, in which the smaller of the asteroids was hit with one of these satellites from NASA, where the inclination or the orbit was changed. Now this is one of the ideas where, in case of some sort of catastrophe where a potentially hazardous asteroid, it is heading towards the Earth, then we can redirect it away from the Earth. Such testing was done at a smaller scale in the DART mission. Apart from that, NASA has also launched the Psyche mission to study the Psyche asteroid in 2021 itself. Lucy mission is also planned. Lucy mission, it is going to study more than 8 Trojan asteroids in our solar system. So scientists are calling this as asteroid autumn, because from last decade or so, a lot of research is going on to study different asteroids, to unravel the secrets or the mysteries connected with the origin of our solar system. So these are some of the other missions. Again, Hayabusa by JAXA. Apart from that, all the other missions are by NASA itself. Please remember this. Again, if there is any update on asteroid based projects, we will have a discussion again on StudyIQ for sure. That is it right now in this particular interaction. Thank you for watching this video, and if you like this video, you can always follow me in my social media handle @RahulSai222. Thank you again. Jai Hind.